Hello and welcome to the first ever physics assignment thought process video. Just for clarity before the video begins, I would like to state that I will not be solving any of these problems in their entirety, but rather just giving you the thought process and methodology behind how to solve these questions. So let's begin quickly. Question number 1. To push a 59 kilogram crate across a frictionless floor, a worker applies a horizontal force of 226 newtons. The crate moves 5 meters. Determine how much work the worker did on the crate. This is a simple question. The mass is, you could disregard the mass in this situation. All you would do is take that Newton force. Ooh, 1 second. Okay, you would take that Newton force and multiply it times that distance traveled. So simple enough of a question. Second question, another 17 kilogram crate is pushed, this time up a 16-degree incline. 423 Newton force is applied parallel to the inclined surface. What we need to keep in mind is both the force and the displacement are in the same direction. So the angle is going to be 0 in this scenario, which is very important. The 423-degree force is pushed 3 meters. So all we would do is disregard the angle and the mass this time, and you just take the Newton force of 423 and multiply that times the displacement once again of 3 meters. Okay, now moving onward. Question 3. How much work does gravity do for a brick that falls? Very simple question. Work, change in energy. So you take the potential energy change, so mgh minus mgh, which it's just going to be final minus initial. Initial is going to be, initial is going to be, so it's 0 minus mgh, final minus initial. Final is going to be 0 when it hits the ground. Initial is going to be mgh. So you would take the mass value times gravity, remember that's 10, and you would multiply that times the height, which is 50. So 4.2 times 10 times 50. And this works because of the conservation of energy, where the change in energy is going to be equal to the work that is done. And do not plug in a negative value. Simple and straightforward. Fourth question. A ski lift raises a certain number of passengers, each weighing a pretty heavy amount, of 190 meters in 84 seconds. Okay, this is a fun question, and it requires you to use 2 of the energy conservation laws. First, you want to find the total mass, so you take the number of passengers times each one of their masses. You would get the total mass. I'm going to put that as m. Take m, and you want to find mgh once again. You want to find the mgh value, and if you find the mgh value, well, the change in the mgh, or potential energy, is going to give you the work. So the total mass times gravity, which is 10, times the height here in 190, is going to give you your potential energy. And your potential energy divided by your time of 84 seconds is going to give you your answer of the power required. So simple and straightforward. Once again, I won't be solving these questions. I will give you the thought process behind the questions instead. Question number 5. 56 kilogram woman runs up a flight of stairs in 4.92 seconds. Same thing, just solve for mgh. Not too hard. Question number 6. Calculate how much work is done by the brakes of a certain kilogram car coming to rest in 17 meters per second. You may go and say, well, I have the velocity and the mass. Now, how would I find the force times the distance? Well, keeping one thing in mind once again, finding the difference in kinetic energy would tell you how much work is being done. So you take the final kinetic energy, which in this case is going to be equal to 1/2 mv squared, and that's going to give you how much work. M, your value is given, V, your value is given. Pretty straightforward question. Let's move on to question 7 now. Question 7 is a spring question. These ones are fun. Remember the formula 1/2 k delta x squared, or displacement squared. K being your coefficient of elasticity, I believe, in some sort, normally used for elasticity. Okay, so directly plug this in. Make sure that when you do the distance, for example, this is 4.1 centimeters, do not plug in 4.1. Plug in 0.041. Easiest way to make a mistake on this question. And now that you have the kinetic energy, you take that kinetic energy value that you found out, and the question is asking for the velocity. Be careful about that. How do we find the velocity once... Oh, wait, no. Why am I even bothering? You just solve the velocity by plugging that same question into... One sec, let me read it over. Oh, yeah. Kinetic energy. Same kinetic energy cannot be applied to 1/2 mv squared. So all you want to do is set your equations equal. So 1/2 k... I'll just put displacement as d for now. X squared is equal to 1/2 mv squared. Cancel the halves. Kd squared over... So kd squared over m. Take the whole square root of that. Is equal to your velocity. Pretty straightforward and simple. Next question. Question number 8. One sec. Okay, question number 8. A stone falls from a height of blah, blah, blah. What is its potential energy when it starts falling? MGH. Nothing more to that question. Question number 9. Another stone falls. Another height. MGH. Question number 10. A stone falls again. Oh, okay, this time it's velocity. That makes so much more sense. Okay, so all I want to state is that potential energy turns into kinetic energy. It's pretty straightforward. Potential energy at the very top is equal to the kinetic energy at the very bottom. Conservation of energy. Energy changes from potential to kinetic continually when it is falling. So in that sense, all you would do is set the equations mgh is equal to 1/2 mv squared. You have all values given in the question except for v. You're solving for v. Pretty straightforward and simple. That's how you would solve that question. Question number 11. Determine how much work is done by raising... Same thing. Okay. Work. You're going to find the final potential energy. Oops, one second. Final potential energy minus the initial potential energy, which is 0. Makes your life easier again. So, as every other question, the way to solve this is just MGH. Yeah. Question number 12. Question number 12 states that a certain weight mountain climber climbs a pretty tall mountain, half the height of Everest, I'm guessing. Change in the potential energy. I don't think I need to say much here. I'll just write it once again. MGH. Question 13. A car is brought to rest from a certain velocity. If the car travels 62 meters, how much force was required? Okay, same thing. Change in kinetic energy is equal to work. Change in kinetic energy is equal to work. Remember this. This is key for the entire assignment, probably the entire unit. Change in kinetic energy. Initial kinetic energy is whatever the velocity of the car is. Squared times mass times 1/2 mv squared. Again, solve for that. Final kinetic energy, it is fully stopped. Now it's potential again. So you would just take this value and then just divide it simply by the distance. Why the distance? Distance times force is equal to 1/2 mv squared. So divide by the distance. Oh, I wrote the distance directly here. I'll just change that. Okay. Is going to equal your force. So, force, yes. Question 14. Another spring question. Pretty fun. The spring of a spring gun has a force constant, elasticity, whatever you want to call it, of that, compressed 8.5 centimeters, the mass, same exact thing. What height would it come to? This is interesting to realize that, once again, potential energy doesn't only convert to kinetic. Kinetic can convert to potential. So as it goes up, the kinetic energy initially is going to be the potential energy final. Okay, so in that case, solving for the kinetic energy would just equal 1/2 k delta x squared. Keep in mind, this value is in centimeters. Converted to meters, we are using the SI units, or I don't MKS, I'm pretty sure. MKS system, same thing, SI or MKS. Convert it when you solve for that. So your 1/2 k delta x squared is going to equal mgh. All values are given except for h. Solve for h, pretty simple equation. You would just do your 1/2 k displacement squared divided by mass times gravity, or just mass times 10. Gravity is the same. And that would be the entire physics assignment. It's pretty simple. It shouldn't take too long. All the concepts are really repetitive. And that's all for this video.